So, calculating acceleration from speed-time graphs. First of all, interpreting the speed-time graphs extended. So, if there is a change in object speed, then it's accelerating. It can be either accelerating or deceleration, but overall it's called acceleration. An object may accelerate at steady rate, and this is called constant acceleration. And on this graph, it's called straight line. So every 20 seconds, the speed is increasing by 5 meters per second. So this means for every second, we can calculate it A equals to V over T. So we have got A acceleration if V A equals V over T, so 5 over 20. So in this graph, we have got the gradient of 0.25, and that's why the acceleration is also 0.25 meters per second square. So now this was the constant acceleration now, and we have the acceleration, increasing acceleration. So this is not there is no constant rate for acceleration. There is increasing object may be accelerating at accelerating rate. So this means, for example, for it at first it had 0 meters per second, and in the 1 second it gained 5 meters per second, and in the second it gained 7.5 meters per second. So this means in the acceleration there is 2.5 meters per second. So this is calculated by upward curve on the speed time graph. So increasing speed by 5% takes less time. So as you can see, increasing from 0 to 5 is taking 40 seconds at first, and then it's becoming less and less. And as you can see, now at the end, it will be so little that it's not visible. An object may accelerate at decreasing rate. So it will be downward curve on the speed time graph. So as you can see here, it takes longer and longer time to speed by 5%, and it at the end it will even take more than the whole graph that continued here. So calculating acceleration. To calculate acceleration, as we saw above, acceleration equals to gradient of the speed time curve. So to find the gradient, we should find rise over run, and this is speed over time. So we should calculate the change in y coordinates and change in x coordinates. How to find the how to find gradient of speed time graph. We have worked example. Dora is training for a cycling tournament. The speed time graph shows her motion as she cycles along a flat, a straight road. So as you can see here, the graph in which section A, B, C, D, or E, the speed time graph is Dora acceleration is largest. So we should find the part with the largest gradient. So it's not absolutely B because 0, and it's not absolutely C and E because all of them has 0, because there is no change in y. So for B, we have got change in y is 5 and change in x is 5. So that's 1. And in D, as you can see here, change in y is 5. So 5 over 2 and 2.5. So for part A, it's B, part D. So calculate torus acceleration between 5 seconds and 10. 5 and 10, as we calculated, 5 over 5, and that's 1. Now we have got 1 meters per second squared. That's our answer. So we will move on to the free fall. So the free fall, acceleration of free fall. In the absence of air resistance, all objects fall with the same acceleration. While learning free fall, we will consider there is no air resistance, because all formulas work when there is no air resistance. But in real life, there is air resistance. So And we have the constant acceleration of free fall rate, and for Earth it is 9.81 meters per second square. So this is called acceleration of free fall. In the absence of air resistance, Galileo discovered that this number. So the symbol G stands for gravitational field strength. So that's why the weight has the formula mass times G and the gravitational field strength. So the motion of falling objects. In the absence of air resistance, all objects fall in this fall with the same acceleration as we said before. So long as air resistance remains insignificant, the speed of falling object will increase at steady rate with acceleration of g. So as you can see here, this is the graph that describes it. In this graph also, it's in the absence of air resistance. Falling objects with air resistance. Falling objects with air resistance, there is two forces that is against our gravitational field strength, and this are weight and friction. So we will learn that in the next our lessons that there is terminal velocity due to this. Skydiver jumping from a plane will experience a downward acting force of weight and an upward force of air resistance. So as you can see here, large resultant force and weight is downwards and air resistance is upwards. So resultant force is being 0. So initially the upward air resistance is very small because the driver cannot Skydiver is not falling very quickly. Therefore the unbalanced forces on the Skydiver are initially. So as Skydiver speeds up, air resistance increases, eventually growing large enough to balance the downwards weight force. And when they balance and there is a resultant force of 0, this is called a terminal velocity. So terminal velocity is the constant last constant speed where the force of weight and acceleration will be equal. When Skydiver opens a parachute, the air resistance increases due to the increased surface area, and that's why the after opening the parachute, the object will start deceleration. Eventually, forces balance out again, and new slower terminal velocity is reached. After the air resistance will be higher for some time, and deceleration will be happening, and after some time there will be again terminal velocity with lower velocity. So worked example, small objects fall out of an aircraft. Choose words from the list to complete the sentences below. The weight of an object is produced of the object mass is. So as you can see here, the weight of object is the product of object's mass and gravitational velocity. So this formula W equals m times g. When an object falls initially, it accelerates and then it reaches the terminal velocity. As the object falls faster, the force of friction acting upon increases, and so we learned this also. Eventually the object eventually object falls at steady speed. So the terminal velocity has got synonym called steady speed. So I will post this site to the video, and you can review what we learned in this lesson. So goodbye.